Yo, what's up, guys? Welcome back. I think episode 165. I think. Shit, I don't even know what I put on the video. I think 165. Yeah, 165. Yo, what's up, guys? Welcome back. Appreciate all the love. This is gonna be a quick stream, just cause I'm going to watch Superman later. Well, not later, in about 45 minutes with my buddies. But I didn't want to miss out. But I also wanted to make a video too. So I guess we're going to do that right now. I'm going to set up our little environment here really quick. I think we're going to aim to do one problem today, probably. So that's the goal. See, what are we looking at here? That looks good. Let's take a look at our daily problem. Find the maximum length of subsequence 2. I think we're going to leave this one for today. We're going to jump into a graph problem. What I said in the description. So let's look for a graph problem. We're going to have graph theory here. Jump game, shortest to get all keys. I feel like I only have 45 minutes here, so I have to think about this well. Let's take a look at our sorry, I got some shit stuck in my teeth. Maybe we'll take a look at a 1500 problem and just see where it takes us. Actually, fuck it. Let's do course schedule 2. Right, we'll do this problem and then oh, whoops. Reset. Okay. I want to see how much what course schedule. Course schedule 4 is 1692. This is course schedule 2, so not rated. Okay. So there are a total of num courses you have to take, labeled from 0 to num courses minus 1. Ah, man, my eyes hurting a little bit. Let's see here. Which is a problem we have looked at in the past. Solved on April 21st, only attempted it once. I do remember from memory, though, that this is a tough problem. At least it was for me. We are a little rusty on graph problems. It's been a while since I've done one of these, so there are a total of num courses you have to take, labeled from 0 to num courses minus 1. You're given an array of prerequisites, where prerequisites AI, BI indicates that you must take course BI first if you want to take course AI. So that's similar to course schedule 1. For example, the pair 0, 1 indicates that to take course 0, you have to first take course 1. Found the ordering of courses you should take to finish all courses. If there are many valid answers, return any of them. If it is impossible to finish all the courses, return an empty array. So I've got a bigger example here. So we're given prerequisites 0, 1, 0, 2. There are a total of 4 courses to take. To take course 3, you should have finished both courses 1 and 2. What's up? What's up, Galactic, dude? Good to see you. No, sure. Good to see you, too. Yeah, early stream today. Yeah, Galactic. I'm only going to be streaming here for about 45 minutes. It is a little bit early for me, but I'm going to see Superman with some friends. They're literally going to be here in 42 minutes, so I didn't want to make an excuse to make a video, so I wanted to jump on and stream, just probably do one problem. Have we done this one before? I have done this before, and I think I've done it in one of the videos. I would say that I did this on April 21st, so I would say I probably did this at about like 100 episode mark or something. Maybe a little earlier than that, maybe like 80 or 90. I don't know. But I'm looking at this one again, so it's been a while. Okay, so four total courses to take course 3. You should have finished both courses 1 and 2. Both course 1 and 2 should be taken after you finish course 0. After you finish course 0. Okay. So one correct course is 0, 1, 2, 3. Another correct ordering is 0, 2, 1, 3. Okay, so I assume from here what we have to do is we have 4 courses and we get all the prerequisites here, right? And we pretty much just have to form the prerequisites. So every time I think about a graph problem, 90% of the time I literally think of an adjacency list, building the adjacency list, right? That's the number one thing, right? So I'm going to build a little helper function here. What do we want to call it? Adjacency list. And we're going to pass in, well, we can just call this edges, I guess, right? We'll call it down here. Let's call our adjacency list. We'll return a hash map here. We'll do adjacency list. We'll pass in our num courses, right? Let's just get a little example here. So we can get something, look at something on the screen. I feel like that's important. Oh, that was a bit too loud. Not a bit too loud, sorry, a bit too big. Still too big. Shout out to Galactic. Show me this shit. This shit's goated. It's way better than Paint or the other bullshit on Linux that you get. Okay, we got our num courses 4. There's another one that's good too. I like Milton, if anyone's ever heard of it. This is a good one too. But anyway. I prefer the web-based version here. It's a little easier. Anyway, so we're getting 4, right? So what I'm thinking here is that we want to create, I'm thinking a hash map, right? Hash map to do our adjacency list. You can do it using an array or you can use it in a hash map. For me, I think a hash map is the most intuitive. How am I going to store this? Well, we're given a prerequisites array. So to take total 2 courses, to take course 1, you should have finished course 0. Okay, so A is a course that you want to take, 0 is a prerequisite, right? So I guess we can set that up here, right? So we pretty much want, in this case here, if we were to take these prerequisites, we would want, okay, so to take course 1, we need course 0, right? So course 0 here would be our key, and then these would be our extra courses to take, right? So we'll have 1, and we'll have 2 here, right? And then we'll have 1 here. The prerequisites to take 1 will be 3. And then to prerequisites for 2, I don't believe we have any, so 2 will be empty. And then for 3, you would need 2. Did I do that right? To take course 0, you need 1 and 2. To take course 1, you need 3. Take course 2, you need nothing. I think I'm taking this the wrong way. Our full total course to take course 3, you should have finished both courses 1 and 2. Oh shit, I fucked this up, dude. Shit, my bad. I fucked this up. I didn't read this properly. Whoops, 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 whoops. So 0. So to take course 1, you should have finished course 0, right? Shit, I'm thinking about it wrong. Holy shit. Wait, hang on. To take course 1, you should have finished course 0. So to take course 0, you need to take course 0 in order to take 1. You need to take course 0 in order to take 2. You need to take course 1. I don't believe they have a 1 here. So then 2, to take course 2, man, I think I'm confusing myself here, dude. Holy shit. To build this adjacency list. So here I know what we can do here is we can do, well, for I in range length num courses, -1, because we don't want the 4. We start from 0. So we would do, okay, graph I is equal to the empty list, right? So this here, this would generate our, I guess, values, right? And I guess we can think of it like this, right? Let's return our graph just to make sure we get that. It's been a while since I've done a graph problem, so just trying to think about it. Oh, has no length. Oh, we don't need the length, right? Because it's an integer. My bad. Cannot access free graph. We're not generating, we didn't create the graph, so graph is equal to dictionary. Okay, there we go. Perfect. Okay. So now how do we want to generate these numbers? I'm literally confusing myself while I'm reading this. So to take course 3, you have to finish both courses 1 and 2. So how can we think about this? We can think about it, the way I'm trying to think about it is we can think about it in 2 different ways. We can think about to take the course or to take. But what's the best way to develop this adjacency list? I guess it depends on how we want to code it, right? Or how we want to do the solution. 0, 1, 2, 1. So to take, so really when we want to loop through this, we're going to loop through each num course, right? Up to num courses -1. So we want to start with 0, right? So to take, so to take course 0, we don't have a prerequisite, right? Okay. So for edge in edges, right, we can do, okay, well, if graph, I guess we want to split that into AB, right? AB is equal to edge. If A not in graph, right, then graph A, we're going to get rid of this. I don't like this. I feel like this is just kind of shitty. Okay, we can check here. If B not in graph, then we can generate it as well. Graph B is equal to this. Then what would we want to do? Well, we'd probably want to do graph B dot append A. That's what we're doing here. We're using our B value here, and then we are appending A, right? I don't know if this is the right way to go about it. Right, and then we return our graph. We're already doing that. Oh, whoops. We're already returning our graph. So let's see what that gives us here. Int object is not iterable. What is edges? Num courses. Whoops, we meant to put prerequisites. That is why we're getting the error. Prerequisites. Okay. Okay, looks good. Looks good. Alright, so we're generating everything. Right, and that's what we had. Right, we had 0, 1, 2. We would have 2, 3. Shit, 2, 3. And we would have 3, nothing, right? or 3 empty array, I guess. Right? Okay. So how can we translate this to code? Well, where would we want to start? Well, we want to return the ordering, the course order, right? So technically, I think the way to start would probably be we want to loop through for course in range num courses, right? -1, because 4 is never going to exist, right? I guess we're looking at this case here. 4 is not going to exist, so I do -1 because there's 3, right? We want to call our DFS function, right? So probably solve this using DFS, so we probably need another helper function here. Probably def DFS. We'd want to pass in our current node that we're looking at. We'd want to, I guess it's not really a node, but whatever it is, pass in our node. Then we're going to need, when I think of a DFS function, we're going to need a path, or I guess some sort of visited array to track what we visited. A path. And I think that's really probably about it for now, unless we think of something, right? Here we want to return, okay, well, if what would be our if here? Probably want our visited. Let's define our visited here. We want to do, how would we want to check this? Well, I usually like to think of this, I guess maybe we can somehow have our res here. Maybe what we can do is we can loop through every single course, and then if our path, right, is equal to 4, for this case here, if our path is equal to 4, we can check, well, if our path, if the length of our, I'm going to change color actually. If the length of our path, right, is equal to num courses, I'm going to call it nm, then this is when we would return, right? Or is there any other way we can do it? Maybe with the Boolean or something? Trying to think here. I don't really know. I'm thinking this is probably the best way, but I don't even know if this will work, to be honest. I guess we could just fuck around and find out, you know. Anyway, let's call our DFS function here. DFS, we can pass in our course. We can pass in our visited, right? And then pass in, we probably want an empty set for our path, so we can keep track of our path each time, right? An empty set here. But how can we track it? If I guess if this returns true, we can do if this returns true, then we can do. Can we just set like res to be equal to for now, let's just append I guess maybe we can append it in here. So maybe we wouldn't even need to return anything. I guess if it returns true, then we can just return our res, right? We can return from this function and then instantly return our res, right? If we're going to append it. I don't know. If we can't find anything, what will we return? If it's impossible to finish a course, return an empty array, right? So we would just return this. Okay, now if we want to implement our DFS function, how are we going to implement this? This is the tough part here to implement this DFS function. So obviously one of our base cases here will be, okay, well, if the length, what we were thinking, if the length of the path is equal to the length of the path is equal to node, or sorry, is equal to num courses, then we're instantly going to do res.append path, right? And then we're going to return true, right? Otherwise, if our length, what would be another base case when we want to terminate? Well, I guess if we've already visited, right, the array, right, we won't want to be going back, then we're going to see a cycle, right? So if node in visited, right, this is where I think we would return false, right? Because then we have seen a cycle here, right? This would be a cycle detection right here, okay? Then we'd loop, and we would go, okay, well, for neighbor in graph node, if DFS neighbor, right, we want to pass in our neighbor here, we want to pass in our visited, and we want to pass in our path, right? I guess technically we don't even need to pass in our visited, low key, because I guess really all we'd need would be path. Wouldn't even need to pass in visit, because visit is global. So, and that reminds me here, we need to do visited, we need to do, hang on, sorry, we do path.add, right? Add to our path. We call path again on the neighbor. For neighboring graph node, if DFS neighbor path, right? So if we do return true from this case here, then we return true from everything, right? Then out here, if we get past this, then we would want to add it to our visited, visited.add visited.add node. And I believe out here what we want to do is we would probably path.remove node, and then we would just instantly return false. So let's relook at this code. Our base case being if the length of path is equal to num courses, we would append. If node in visited, we would return false, right? So if we visited the node already, we return false. Would it be that? Path.add node for neighbor in graph node, if DFS neighbor, return true. Goes out of this loop. If we come out here and we get through everything, we can add visited. We've processed that node fully. Maybe do we need to remove our path here though? I don't know. I'm not sure. Let's see how this goes. Probably trash code, dude. Let's remove our visited. We don't have a path here. We have to pass in our set here, new set. Will this work though? Because technically we're looping through each course and we're keeping a global variable of visited, right? So technically maybe if our 0 was empty and our 1 was empty, is it turn the ordering of the courses you take to finish all courses? So maybe Maybe I'm wrong, actually. Maybe the length of path won't be technically the end. Maybe the length of path won't always necessarily be equal to num courses. Is there a case where we don't? Yeah, I don't know. There's a lot to think about in this problem. This is a tough problem, dude. Like, course is not defined. Where is that? Yeah, it never reaches our base case here. Dude, I am not sure. I feel like I'm thinking about the problem in the right way. Like I'm having the right intuition, but I just feel like I can't. I feel like I struggle with translating it. To code. Then again, this is a very tough problem, I feel like. So I'm not too... So... For neighbor in graph node, if DFS neighbor path return true. So we're just not getting here, right? We're adding our path each time. Right, we're looping through. Really from here, how should we go? We should go, well, how would our DFS go here? Right? Let's think about that. We start off at 0. Well, we need a drawing thing. We start off at 0. We would go to 1. 1 would have nothing, right? So we go down here and we do visited. No, sorry. We'd loop through here. We'd add 1 to the path, right? So our path technically would be 0, 1, right? This is our current path in our set, right? We get here. We'd see it has no neighbors. So we do visited.add node. So our visited would have 1 in it, right? This can be, I'm going to set visited here, and this can be P for path, right? We will remove, right? So we remove 1. We go back to 0. We'd pass in 2. 0, 2. Right? Then we'd see 3. So we would add in 3. So really, we never actually get to this base case here. 0, 2, 1, 3. 0, 1, 2, 3. So we could have returned it here, but we're removing this path. So maybe if we got rid of this, it would pass 1 test case. Nope. Type error. What are we returning? We're returning a list of a list. I think that's our issue here. We got to do... Let's do return res 0. Will that fix it? This index is out of range. Okay, that's not going to work because not every time there's going to be something in there. So maybe we can just make res equal. Is that possible? I've never really done this. Res is equal to... We can do list of path. I don't know. I have no idea if this would work, but... And then we return an empty... Nope. Not coded, not coded. What if we leave res.append, we keep the empty string here, and then we just return res 0? Because at least when we get here, we know that we've appended something, so res 0 will always be valid. Nope. Maybe it just doesn't like that return type. Um, this is crazy. What if we did like array is equal to res this, and then we return our array? That's fucking stupid. Like, we just return our res. To list of path. We're still returning nothing. Are we getting here, dude? Let me print here. Are we getting here? Get here. Print here. Are we getting to this point? Nope. Oh, we do get here. Okay. But we still output nothing. So we get in here, we output, we make res equal to list of path, then return true. Obviously that doesn't work, so I don't know. So we are getting here, so I think we are returning the correct thing. Let's print our... No, we won't be able to print it. I guess we can print res. Hey bro. 10V. What's up, man? How you doing, dude? Thanks for joining the stream, bro. It is an empty array. That's interesting. Yeah, you know, I'm not sure. I'm gonna need some help with this. Guess where I am from? No idea, bro. Shit, dude. I don't know. California. I got no idea, bro. No idea. You could be you could live anywhere. Where are you from? Use ChatGPT to solve it. Dude, then I won't learn anything if I use GPT to solve it for me, bro. Poor GPT. Bangladesh, dude. Let's go, bro. Good stuff, man. Good stuff. Is Bangladesh nice, dude? I've never been there. So I did type this in. Seems like here we were on the right progress, but on the right track. So they do create the adjacency list. We have two separate sets. Seems like we did get it right here. So we do create this adjacency list. So this is correct here, right? I think we just kind of messed up our DFS logic a little bit. We loop through each course here. Right, so instead we're trying to think of a way here to return true, but really what we should do is, like, they have here, if not DFS. So they just pass in one course. They would instantly return an empty string, right? And instead here, they would return res. So I think... So they do define their sets here like we did. They have a visited and they have a visiting. I'm going to call this path because that's what I usually would call this set. Then they have their res, right? Same thing, right? And then we call our DFS function here, right? We had the base cases here that they have. Damn, I feel like I kind of just fucked it up. So they have if node in visited. Are you doing self-learning? Which IDE you are using? I am... Oh. Academic purpose. Are you doing self-learning or your academic purpose? Probably more self-learning, I would say, probably. I just do it for fun. I do these Leetcode style problems for like an hour every day, and I just stream myself doing them. They're fun. I enjoy it, so probably more self-learning. No academic purpose. Anik, which IDE are you using? I'm using Leetcode's built-in IDE. Usually when I'm booting into Windows, I do the problem in C++. Because I am learning C++, but for today, I'm just going to be doing the problem in Python because I'm going to the movies with some friends soon. So probably don't have enough time. But here we did get our base case kind of correct. If it isn't visited, but think about it in a different way though. I think they put if node in visited, they return true. But then if node in path, we return false, right? And I believe here we return false here because return false, this would be a cycle, right? This would be a cycle here. That's why we're returning false. If it's in our path set, we return false. If it's in a cycle, we return true. We add to our path, right? We loop for neighboring graph node. If DFS neighbor path, I guess technically they're not passing in path here, but trying to think here. Definitely a tough problem. I would say this problem is definitely probably higher than a 1500 level problem for sure. Probably maybe 17, 1800 maybe. This is a tough problem. Okay. If in path, I forgot node. If node in path, we return false. We have our visitor here. We have our path.add. We have our for neighboring graph node. If DFS neighbor path. So maybe this should be changed to false, right? Because if we have a cycle, it's not going to work at all, right? We will return false. We have our... I am a computer science student. Nice, man. Where do you study at, bro? And what year are you? I've graduated already, so I've been going at it for a little bit, but where you study at, bro? Here we'd probably remove our path. Path.remove node. Add our visited. And then res.append. We append the current node that we're looking at. We return true. Get rid of this return false. See what that gives us here. Oh, we gotta pass in our path. Path. We are getting the wrong answer here. Leave is just the other way around. Res.reverse. Is that how we do it in Python? Northern University in Bangladesh. Nice, bro. That sounds... Oh, output. All null. I believe... Northern University in Bangladesh. Let's look it up, dude. I'm curious. Bangladesh, dude. Let's check it out, man. Let's go, dude. Looks good, bro. What year are you? I went to Eastern Illinois University. If you've ever heard of it, bro. I went here. It was literally in the middle of nowhere. In Charleston, Illinois, dude. There was like a little castle, bro. Had fun there, dude. It was a good time. Very small school. I played tennis there too. Got a scholarship to play tennis. It was fun, bro. Really good time. Highly recommend this school, man. Goated school. Anyway, I believe here now we just need to reverse this. I think to reverse this I think that's how you do it in Python. Okay, we're missing something here. Prerequisites is 0. Output is 0. Expected 0. Why are we expecting 0 here? Num courses is 1. Prerequisites is here. We would just return 0. I believe we have to get rid of the -1. I think that's our issue. No, key error. Maybe not. So let's think about it. Why is this returning like this? We go 4. 1 second, guys. 1 second. My buddies are here. Gonna go watch Superman. JC list here. Definitely some small bug here, bro. I just don't know what it is. My buddies are here waiting for me, dude. Return. Okay, so we loop through the course. Here. There's nothing inside though, so we would come in here. We'd start at 0. We'd add it to our path. We'd see that there's no neighbors. We remove from our path visit.add res.append node. But why are we not appending 0 here? Oh, it's because we are returning this. So maybe, what if we just return res here? Are we going to get the right answer? I don't know. Nope. I'm not sure. I'm not sure what my bug is, guys, and I don't have time. What is my bug? You're very close, but the main bug in your code is this line. So I was right, dude. It was this line, bro. But I got a key error here. Why am I getting a key error? Of course not in visited. I think we need to add this line here. That's why we're getting our key error, I think. Nope. Now we're getting a key error here for neighbor in graph node. I've subscribed you. Wish you all the best. Thank you. Thank you, 10V, bro. Thank you for that, bro. It's appreciate it, dude. I'm making a little Discord community if anyone wants to join. I have it in the description of the video if anyone's interested in joining. We got about like 20 people in there, so pretty fun. Why am I getting a key error here though, dude? I have no idea. Key error, that means I'm accessing something that's not there, but I don't know. Maybe is it something to do up here? For AB and edge. If A not in graph A is equal to this. If B not in graph B is equal to this. If anyone sees why I'm getting a key error here, I'd really appreciate it. Okay, so I believe this here needs to be a default dictionary, apparently. Is that what it is, bro? So if this is a default dictionary here in Python, if people aren't familiar, that means we don't have to specifically do this, right? So we can get rid of this. We can just leave it like this, but we can make this a default dictionary, which means every single time that we access a key, it won't be invalid. It'll always return an empty list. Let's see if that makes a difference. There we go. I think that's our issue. There we go. Whoa. We had the right idea, the right thinking, the right way to approach the problem. I'm actually pretty happy with that. I think last time I really, really struggled with this. So, you know, I guess it's showing a little bit of improvement here. You got to relook at that problem. I guess we can look at the submissions. I did this on April 21st, so about 3 months ago. So, pretty happy with that result. Felt pretty good about it. I guess we can take a look how I did it last time. I believe I probably watched a video to help me solve this at first to get the right idea. But we did solve it a little differently, but I mean, kind of the same thing pretty much, but just a little different. But yeah, it was great. I appreciate you guys. Thank you guys all for watching. And I will see you guys tomorrow. Sorry it was a short video today. I'm going to watch Superman with my buddies. So appreciate the love. Thank you guys for watching. And I will see you tomorrow.